Ever heard that one about the statistician describing, like, population trends but using pi?
Hmm.
Yeah. Sounds like a joke, right?
Yeah.
But it kind of gets at this almost eerie connection between abstract math and the actual world around us. Like, that's what we're going to be diving into today. We're tackling these really mind-bending ideas from Eugene Wigner from his paper called The Unreasonable Effectiveness of Mathematics in the Natural Sciences. So yeah, get ready, because this one really goes deep, I think.
Yeah, Wigner's really wrestling with this question that's been bugging, like, physicists and mathematicians for ages, you know?
Yeah.
It's like, why is math so unbelievably good at explaining, like, the entire universe? Like, it's almost as if the universe is playing by this rule book, but the rule book is, like, written in pure numbers.
Okay, so to really unpack Wigner's argument, let's start with how he defines, like, math and physics in the first place.
Sure.
So he describes mathematics as this almost playful exploration of concepts.
Right.
You know, like pushing the boundaries of what's even logically possible.
It's like, imagine a mathematician, right? They're like an explorer charting some completely abstract wilderness.
I like that.
And they're creating the map as they go, you know?
Right.
Testing the very limits of logic with every single step. But what's so fascinating is that they're somehow able to do this while avoiding, like, contradictions, right?
Right.
They're ruthlessly exploiting the domain of permissible reasoning, as Wigner puts it.
And I think that's such a good point, because it's not just about, like, you know, finding the simplest answer. It's about uncovering these really elegant and interconnected truths that often have zero obvious connection to the physical world. They're just kind of there.
Exactly. And then you've got physics, which Wigner sees as this quest to uncover those laws of nature.
Okay.
Like the actual guiding principles behind how the universe ticks.
Yeah.
You know, it's like searching for some sort of order in what could have just been pure chaos.
And it's so wild how often these two worlds, they collide. Like, think about matrices and Hilbert spaces.
Yeah.
I mean, these really abstract mathematical concepts, they sound like something out of science fiction.
They really do. Yet they're absolutely essential to quantum mechanics, which, you know, is a theory that actually explains the subatomic world with crazy accuracy. Imagine, like, trying to organize all this information about the universe, but you're using this massive, massive spreadsheet. That's basically what matrices are doing in quantum mechanics.
Wow.
Who knew that such a tool could even exist, let alone be, like, the key to understanding reality on its most fundamental level?
Yeah, it's almost like mathematicians were, like, unwittingly writing the universe's instruction manual, and that's what Wigner finds so baffling.
Yeah.
It's not just that math is, like, helpful or useful for physics, it's that it seems to be the actual language of reality.
Yeah.
Even when those mathematical concepts were developed with absolutely no intention of describing the physical world.
And that's the core of this whole unreasonable effectiveness idea, right? It's like we've stumbled upon this secret code book to the universe.
Right.
But the code was already written, just waiting for us to discover its meaning.
It's wild. So we've got this incredible code book.
Yeah.
What are some of the secrets it's actually unlocked? Like, where do we see this unreasonable effectiveness playing out in the real world?
Well, Wigner, he gives us a few really compelling examples.
Oh, yeah.
And one of the most classic ones got to be Newton's law of gravitation.
Right.
It's such a simple-looking equation, really.
It is.
But it describes this force of gravity between, like, any two objects that have mass.
Right. And what blows my mind is how this equation, which is, you know, based on this kind of abstract idea of a second derivative from calculus, ended up describing the motion of everything. From, like, apples falling from a tree here on Earth to, like, planets orbiting stars light years away.
It's like we found the universal design principle for how things attract each other across the cosmos.
Exactly.
It's incredible.
Wild. And this unreasonable effectiveness, it's not just like a classical physics thing.
Right.
Like, Wigner says it becomes even more pronounced when you get into quantum mechanics.
Oh, absolutely.
So we were talking about, you know, matrices, Hilbert spaces earlier, remember?
Yeah.
the giant spreadsheet.
The giant cosmic spreadsheet, yeah.
So take the example of the Lamb shift.
Okay.
Have you heard of this?
Yes, yeah. It's this tiny, tiny shift in the energy levels of a hydrogen atom.
Right.
And it was predicted entirely through math.
Wow.
Like using these complex mathematical calculations with those same tools, And then when physicists actually measured it in the lab,
Yeah.
they're like, holy cow, it matches perfectly.
So they found this like tiny, tiny detail
Yeah.
hidden deep within the atom.
Deep down there.
And the only way we could predict it was through this seemingly like unrelated language of abstract math.
Yeah, I mean, how is that even possible?
That's crazy.
It's almost like math knows something that we don't, you know?
Yeah. Yeah.
It really drives home this point that the universe, at its core, operates according to this deep, inherent mathematical structure. It's really quite amazing.
Okay, this is making me rethink all those like high school math classes that like maybe there was something there.
There was something there.
Okay, so if math is so good, so effective at describing reality, does that mean what we know right now, is that it?
That's a great question.
Like, have we got it all figured out?
Yeah.
Or is there like a chance we're missing some big part of the picture?
That is where Wigner gets really interesting.
Okay.
Because he acknowledges the incredible success of the theories we have now.
Right.
But he also brings up this critical question. What if there are other explanations out there?
Okay.
Like equally valid explanations that we haven't even considered.
It's like that saying, like, if you're the smartest person in the room, you're in the wrong room.
Exactly.
Like, maybe we need to find a bigger room.
Yes.
To fit all these ideas.
Exactly. And this is where he introduces this really interesting thought experiment.
Okay.
He asks us to imagine, what if our intelligence was just a tad, just a bit less developed than it is right now?
Okay.
We'd probably be perfectly content with theories that we right now consider incomplete.
Right.
Or even straight up false.
Because they fit within what we're able to understand.
Exactly. It's like our perception of what's true, what's real,
Yeah.
might just be limited by our own brain.
Okay. Yeah.
Our own cognitive ability.
That's kind of a humbling thought.
It is humbling.
To be honest.
It is humbling. And he gives this example of the free electron theory, which describes, how electricity moves through materials.
Right.
And for a lot of practical uses, it works.
Right.
But at the end of the day, it's a simplification.
Okay.
We know there's a deeper, more complex reality going on down there.
Right.
That this theory just doesn't fully grasp.
It's like we're using a stick figure to represent the entire human body.
Exactly.
It's like, yeah, you've got the basic shape, but it's certainly not telling you everything.
Precisely. And the free electron theory, like a lot of scientific models, is a useful approximation.
Right.
But what if this crudeness, as Wigner might call it, what if it's not just a limitation of some specific theories, but like a fundamental issue? What if everything we understand about physics right now, as good as it is fundamentally at odds with a completely different way of understanding the universe?
Okay.
Like a future theory of consciousness.
Right.
Or biology, And that's when things get really, really interesting and maybe a little bit unsettling.
Okay, yeah. So that's a pretty wild thought right there.
Yeah.
That everything we think we know about physics right now could actually be at odds with like a completely different way of understanding things, like how consciousness works or how life even arises in the first place.
Right, and it's a real head scratcher. And Wigner, he actually calls this potential for conflict a nightmare for physicists. He uses the example of Mendel's laws of inheritance, right? Like the basis for our understanding of genetics.
Right.
And he asks us to imagine if we were to develop this crazy powerful theory for like understanding consciousness or these complex biological systems.
Yeah.
But it totally clashed with everything we thought we knew about physics.
Right. So then what?
We're in trouble. Like how would we even begin to reconcile those two seemingly opposed truths?
So where does that leave us then? It sounds like we're kind of on the verge of this like scientific existential crisis.
Maybe not, While Wigner definitely lays out all these challenges, these potential conflicts.
Yeah.
He also seems like genuinely amazed by it all. He calls this effectiveness of mathematics in the natural sciences a miracle.
Wow.
A gift that we just don't fully get.
It's true. It's easy to get caught up in all the what ifs and anxieties about, what we don't know.
Limits of our knowledge, right?
Exactly.
But when you take a step back, it really is mind-blowing.
It is.
That we've been able to understand even this much of of the universe's,
Yeah.
underlying code. I mean,
It's pretty amazing
it really is.
when you think about it like that.
It really is, and I think it speaks to this deep human curiosity,
Mhm.
this drive to look for patterns, look for explanations, even when those explanations lead to like even more questions.
Right.
You know,
Right.
and that I think that's really what Wigner wants us to take away from all this. It's not about having all the answers.
Yeah.
It's about being okay with the mystery, with the wonder of just exploring, of doing science.
I like that a lot. So as we wrap up this deep dive into into Wigner's The Unreasonable Effectiveness of Mathematics in the Natural Sciences, I think we're left with this sense of awe, but
Yeah.
also this like intellectual humility.
Absolutely. The universe is this place of such profound elegance,
Right.
but also just baffling complexity. And
Yeah.
and maybe we'll never have all the answers, but
Right.
searching for those answers,
Yeah.
that's what makes the whole journey so captivating,
Yeah. And it's like he's handing us this torch at the edge of the unknown,
Yeah.
and he's saying, "Go explore, go see what you can find." He doesn't want to just give us the answers.
No. Well,
He wants us to be part of
this conversation.
It's this ongoing conversation
Yeah.
about the nature of reality, the role of mathematics,
Yeah.
all of it, the limits of what we can even understand.
Exactly. And that's what we've tried to do here today, right? To give everyone a glimpse into Wigner's brilliant mind.
Right.
And hopefully encourage you to keep thinking about these big questions, like if our current understanding of physics really is fundamentally incompatible with a deeper understanding of consciousness, like Wigner suggests, then what does that tell us about reality itself?
Right.
Is there one single ultimate truth out there, or are we always going to have to deal with multiple, maybe even contradictory, but equally valid perspectives on the universe? That's something I think we'll leave for everyone listening to ponder.
It's a great question.